Hello everyone, myself Varadarajan, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology. Today I am going to discuss about some case study in the subject of engineering drawing or machine drawing or computer-aided machine drawing. So these are the subject is very important that to draw and develop and design the product. Research and development area, these are the subject that will be very much useful. Due to the manufacturing of any component, we need design first. So that's why the design is a basic part or base element of the any product on any research and development area. So here we just want to discuss about the case study in the particular subject, limits, fits and tolerance. So here, so we just want to give some introduction about the machine is an assembly of innumerable number of parts, of which some such as bolts, nuts, screws, bearings, gears, chains, sprockets, couplings, etc. are the standard parts, and the remaining are specially designed for the particular machine. So we already know that each and every component, or if you have taken any one machine or any one vehicle, two-wheeler or four-wheeler, whatever the component, whatever the parts, whatever the material, so these are the things. It will be a combination. If we just want to join together, we just want to couple together by using these are the bolts, nuts, screws, bearings, gear, chains. These are sprockets. We just want to transfer one energy from one place to another place. The sprocket is a very mandatory thing, and the coupling also. These are the things, the basic elements of mechanical engineering. So here it will be a very basic thing in the any type of machines. These are the things. It will be coupled, and it will be a number of parts which can be joined together to making a one particular machine in fulfill. So next we just want to see the definitions of these limits and fits and tolerances. Here we just want to show the difference between the basic shaft and basic size, and the minimum shaft and minimum limit, and actual shaft and actual machined size, and maximum shaft and maximum limit. So how the tolerance, limits and fits, how they exactly fit and exact fit, actual fit, it will be taking place in the different shaft material, which will be shown in this particular diagram by actually shown in the dimensions also. So the plus and the diameter, which can be represented over here in the tolerance dimension. So here the particularly overview about the particular dimensions of 30 diameter, plus or minus 0.035 and minus 0.215. These are the tolerance and limits value which can be denoted over any type of manufacturing elements which can be used in the manufacturing plant or production plant. So in the industry, so in each and every industry, when the machine components which can be manufactured by using the machines, which these are the tolerance value, each and every product according to the dimensions, they are checking these tolerance value and limits and fits value, which can be denoted over each and every industrial design drawing, so which can be represented over each and every drawing. So that particular limits and fits value, then according to that we can design or we can develop the diagram of particular thing. So these are the illustration: basic size, deviations, limits and tolerances. Okay, so this is the next definition of basic size and actual size and limits. What is the difference between these basics and actual and limits? So it is defined, basic size is defined as the theoretical size of a part derived from the design after rounding off to the nearest whole millimeter. So this is the basic value. So the whole dimension value, it will be nearest whole millimeter value. So that is the actual size, and the basic size, it will be moreover, it will be little bit different, and it is actual size, it will be defined as the size of actually obtained by the machine. It is found by the actual measurement of by using a measuring instrument. So the quality, whenever after the machining process, by using the quality checking, the quality department, they can check the actual size of each and every component. The whatever the dimension it will be given in the design part, it will be the same dimension which can be obtained, that is the actual size. So the limits is which can be last one, the limits. So the two extreme permissible sizes between which the actual size lies are called the limits. So that is the actual extreme permissible sizes. So that is the limits. Okay. So maximum limit, in that particular limit, there is a maximum and a minimum limit and tolerance level. So maximum limit it is which is defined as the maximum permissible size of the given basic size. So the minimum limit it is defined as the minimum permissible size for a given basic size. So the tolerance it is defined as the amount of variation permitted of the size, the difference between it is defined as the amount of variation permitted of the size. The difference between the maximum and the minimum limits of the basic size is called the tolerance value. So here, and the last one is the deviations. So deviation, which is nothing but here the difference between the actual size or limit size, either maximum or minimum, and the corresponding basic sizes. Actual deviation, it is nothing but the algebraic difference between the actual measured value. So the upper deviation and lower deviation defined as the algebraic difference between the maximum limit of the size and the corresponding basic size. So it will be algebraic difference between the minimum limit of the size and the corresponding basic size. It will be a lower division value. So zero lines and the tolerance zones. Since the deviations are measurement from the basic size, it will be indicated the deviation graphically. The basic shaft of the machine, minimum shaft, the actual shaft, and the maximum shaft are aligned on the bottom of the straight line, are called the zero line in the drawn through the top generator of the basic shaft. So the tolerance zone in the graphical representation of the tolerance, the zone bounded by the upper and lower limits of the basic size is called tolerance zone. So here up to which the particular paragraph, we just want to finish today's lecture topic. We just want to continue this particular case study in the next lecture series. Okay. Thank you very much.